All right, ladies and gentlemen, we have this lesson on surface area, and I hope you enjoyed the last video. This next video focuses on the second of the two methods we are going to, that we talked about in the last video. And that second method is going to be called draw a net. So our objective is that you can use the draw a net method to calculate surface area. This is something that I know is part of the 6th grade curriculum as well. Some teachers insist that you draw nets. I am perfectly okay as long as you make a drawing that you use one of the two methods. You either can just make the drawing of the three-dimensional figure, redraw it if it's given to you in the book, or you can do what's called drawing a net. I'm going to show you how to do that right now. Drawing a net is helpful because basically what we're doing is we take the three-dimensional shape here and open it out and make it into a two-dimensional shape that we call a net. And here's how you do it. Okay, imagine, and I want you to stop the video here, by the way. This should be your second problem for this lesson, and it's involves this rectangular prism. And I want you to first draw it out in 3D, and then I want you to look at how drawing a net works, and that's going to be here. We're going to imagine pulling the small 2x3 rectangles out. Those are the ones on the edges. Go ahead and shade those in. So we're going to take these, this one, and that one, and imagine just sort of having them fold outward, and then unfold everything flat as if it were on a table. And actually, it might not be a bad idea before I show how I did it for you to try it and fiddle around with it for a while. It's a nice method, so let's check it out. So if you unfold everything, what's kind of nice is that you end up with this two-dimensional shape that's fairly easy to analyze once if you unfold it the right way, so to speak. Okay. So here's our two pink shapes. Yeah. Off to the side. And then we have, I'll use a different color here. This rectangle that I've labeled C, and this one that I've labeled A, that are each 8x3. And then we have these other ones that are 8x2. And really our task, now that we've analyzed the number of shapes we have, and you might want to stop and count how many shapes we have, is we just add them up. Okay, so shape A, and again I'm going to suggest that the best way to use this video is to stop and do it yourself. But shape A, it looks to me, is 8x3, which is 24 inches squared. Area problem is always going to give us square units. Shape B is 8 times 2, 16, just using our math facts. Shape C, again it's 8 times 3. Again, this is all assuming that you know the area formula in this video. The area formula is one that we've been working with for years. It's base times height. Shape D, 8 times 2 again. And that's 16. And then E and F are the same, and that's 2 times 3. 6 inches squared. And 2 times 3 equals 6 inches squared. Now, I haven't made my columns for these numbers perfect for just adding them up long ways, but I wouldn't do that anyway. You might notice that 24 and 16 are very tempting numbers because 4 and 6 is 10, right? And so 24 and 16 are 40. 40. And this is 12. And then in your head, you should be able to do 40 and 40 and 12. If you can't, you're just going to add them up in columns. But 40 and 40 is 80. And 80 and 12 is 92. And so we end up with 92 inches squared. All right, so those are our two key methods. And we have make a net or draw a net like that, or it's just drawing the figure out yourself and adding up the shapes, which I call draw and combine. And I'm happy with either of those, but the only thing that would make me unhappy is if you don't do this, if you don't draw. The key to this is to make the drawing. I'm going to be checking your work to make sure that you do. Okay. Now, one more bonus concept at the end here that I don't want to neglect to tell you is that you are going to run into some problems that are surface area problems and that are a little bit tricky because they involve essentially composite shapes, composite three-dimensional shapes. And on those, you have to be careful to look for areas that aren't actually on the surface. All right. So in this case, we have this little kind of house-shaped 3D shape. And I would want you to think about what you might think of if it were a house as the ceiling of the first floor. Kind of shaded in right there. Maybe you guys see that. And I want you to consider how that's going to play out in terms of the surface area of this shape. We're going to assume, by the way, in most of these, unless it tells you, you assume that the shape is kind of floating out in space, that this is not a house sitting on the ground, it's kind of floating out in space. And so this rectangle down here counts. The yellow one, though, doesn't, because that's going to be inside the house. It's not on the surface, it's on the inside. And so for fun, I would suggest that you see if you can calculate out the surface area for this shape, and we'll talk about that later in class. Okay? I hope this was fun for you. I find surface area fun. It's time-consuming, but it pushes on those drawing skills and on visualizing things geometrically, which is really, I think, turns on a part of our brains that is exciting. So, enjoy.